Okay, we're supposed to find all the angles in radian measure between -2 pi and 2 pi inclusive, such that the cosine of that angle is the square root of 3 over 2. Now, if we are dealing with right triangle trigonometry and thinking of a 30, 60, 90 right triangle, in that kind of triangle, the short leg, which is opposite the 30, is the focus of the theorems on the ratios for 30 and 60 degree angles, but the hypotenuse is twice the length of the short leg. And the long leg, which is opposite the 60, is radical 3 times the short leg. And so the cosine of 30, the angle that has a cosine of radical 3 over 2, is 30 degrees, adjacent over hypotenuse. And 30 degrees in radian measure is pi over 6. Okay, so if we look at the unit circle where the radius is 1, any angle that has a positive cosine with a reference angle of pi over 6 will have a cosine of radical 3 over 2. Between -2 pi and 2 pi inclusive, there's actually 4 of those angles. This circle has a radius of 2, so I can put the numbers 1 and square root of 3 on the adjacent and opposite sides, and this means this angle is pi over 6. That's what we call the reference angle. The question is, how can we get to these terminal sides other than just rotating from the positive x-axis in this direction? Well, that's one of the ways. So one of the angles that has a cosine of radical 3 over 2 is pi over 6. But you could also get there by starting here and rotating in a negative direction to get to here. And you don't make it all the way to -2 pi. We stop pi over 6 short of that. So you could think of that as -12 pi over 6 plus pi over 6. That's how far short we stop. That's -11 pi over 6. So the cosine of -11 pi over 6 is radical 3 over 2. And likewise, we could get to this terminal side by rotating in the negative direction, pi over 6 radians. And that takes us to -pi over 6. We could also get there by rotating from the positive x-axis in a positive direction. And once again, we'd be short of the 2 pi. That would be 11 pi over 6. So those are your 4 answers. Here's a graph that kind of confirms it on Desmos. Y equals the cosine of x from -2 pi to 2 pi inclusive is this red graph. If I draw the horizontal line, y equals radical 3 over 2, which is about 0.866. These are all the angles that have a cosine of radical 3 over 2. -11 pi over 6, -pi over 6, pi over 6, 11 pi over 6. Of course, there's infinitely many angles that have a cosine of radical 3 over 2. If we just took off this restriction right here, this red graph would go on forever in both directions. And wherever this blue horizontal line intersected that graph, those would be angles with the cosine of radical 3 over 2. There you go. Hope that helped. If you have any questions, post a comment.